Wait, yeah, I started the recording. Hi again. So we'll be seeing what is there in year 2 and 3. I'll try to keep it as short as possible. So we have classes, we have objects, and what we can do with classes and objects is we can do inheritance. And did you guys study uh, oops in C++ or Java? Hello, C++. Mm-hmm. Okay. Well, it shouldn't be a problem because it's object-oriented program. That's the whole point of it. You can do it in any language. Uh, so inheritance. So you have single inheritance, multi-level inheritance, multiple inheritance, and hierarchical inheritance. So what do you mean by single inheritance? So this is yeah, this is single inheritance where you have eat and you have dog. So dog, wait, wait. You have animal and you have dog. So dog inherits from animal, and the functions and the data members from the animal can be used by dog. So that is single inheritance. And if you extend it in a vertical fashion, that becomes your multi-level inheritance, where a living being and an animal and a dog. So animal is a living being and dog is an animal. So basically, a dog can access the data members and functions of both animal as well as living being. It's like a vertical um, order of inheritance. And then, wait, let's come to this later. So then we have hierarchical inheritance where um, a single class, let's say shape, is drawn out by different subclasses of the same level. So what do you see from here is circle is also a shape, square is a shape, and you can have whatever else. Rectangle is also a shape. So this is a hierarchical inheritance where you have subclasses of the same level inheriting from a single superclass. Cool. And then you have multiple inheritance. So what is the problem with multiple inheritances? As you guys would already know, there's that's called diamond problem. So let us say we have a living being as well as animal. So what we can do is we'll have another class called what is it? So let's say you have let's take another example where there is a class called parent one and there's another class called parent two. Okay, and there's a subclass called child. So now this subclass child inherits from both parent one and parent two. All right. So if parent one has a function say eye color, and parent two also has a function say eye color, uh, when the child class tries to inherit from parent one and two, it doesn't know from which parent's function it should inherit the eye color. Okay, so that is where your problem comes, and it can be solved by using implements. Okay, uh, so that is a different thing. We'll come to that later. So multi-level inheritance is that you cannot inherit from two classes simultaneously. But in C++, I think it can be solved by using friend functions also. So we'll get to there. All right. So these are the different types of inheritances, and you guys should know the examples for each and every inheritance. You might be asked to, you might be given a situation where you have to think about what type of inheritance I should take over there. For example, a place where there is a linear chain of command. So there you'll use your multi-level inheritance, and a place where both can be used, your single level, multi-level, as well as your multiple. There you will use your hybrid, and yeah. So from inheritance, we will move on to something called as so yeah, and for your from your syllabus. So you guys have been given something like this. This is exactly what I think might come for the exam. So you'll be given a set of questions and you'll be given a set of parameters. And I think you guys should be able to know which type of inheritance that you need to choose for the given problem set of statements. Okay. Am I clear till now? Just give a thumbs up. Cool. Cool. And yeah, so basically it'll be problems like this. And even I think it's very implementable paper. It's not like more. It's more of um, you not studying the whole night, and it's just like you go there and then you see the problem and then you implement it. I don't think there is much theory that you need to study. Just have some basic knowledge about what stuffs are. That's all. And then, yeah, these are your classes and objects, right? So from this, we'll come to the encapsulation and dynamic memory later. Yeah, this is what you've been given. So the multiple inheritance can be solved by using a friend function. Okay. So what is a friend function? So a friend function is a function where you define a class and there's another function in another class. So what you can do is inside a class where you want the other function, other classes function, you can derive the same classes, its data members, and its variables from the other class using the keyword called friend. So the class name, this uses the friend of a data type of a function of another class. By using this, what you can do is you can see the example here. So the class called box, right? So it's using print length of box. So what you'll do is when you call print length of B, where B is the box, it can access the function print length of another class using the method called friend. So that's basically it. So how will we ask this? You will be given a situation where you need to inherit from another class, but you need to use its protected as well as private members. So the good thing about using friend is you can use both your protected as well as your private variables, and you can access it without inheriting. Like it extends from Andamari, nothing like that. Okay, you just use friend function. From there, you can just use the function from another class. Cool. And yeah, so you will be having constructors and destructors. And you guys would already know what this means. So this is your UML diagram, right? So I'm pretty sure all of you know how to write a UML diagram. So if and when you are asked, you should be able to give a class name to it, and then its data members, the variables, and you should have its functions, and everything should have been like it should be with their uh, visibilities. So these are the three types of visibilities: public, private, and protected. It should be with the visibility and the function and the parameters that you're trying to take. Okay. So UML diagram is really important uh, because you can be asked to write a UML diagram for the same thing that you've been trying to that you will be implemented. So if you are asked to implement the inheritance for a question, so you'll be asked to write a UML diagram for it also. So you should know what types of variables that you are using and what is the use of those variables. Okay. And yeah, encapsulation. So what is encapsulation? Encapsulation is hiding data members from classes and objects. So basically, you will be bundling your data variables and members. So you will use encapsulation uh, in real world a lot of times because let us say you have getters and setters, right? If you guys don't know what getters and setters is, I'll get there. But if you guys know, I think you would know what I'm trying to tell. So what is encapsulation is? My bad. So what encapsulation does is you will have different types of data types and variables. Okay. So let us say you have a bank account and there is something called as balance. Not everyone should be able to see the balance. Okay, so what you will do is you will declare that variable as private balance. Cool. And whenever you're trying to access the data member or variable, you can't just use, let us say, a bank account B1 dot balance. You cannot use something like that. Okay. So what you need to do is you need to encapsulate the data member by using a keyword called private. Cool. By doing this, you will have access modifiers for these variables. Okay. So by there you will give roles to each and every person. So only these type of people can access it. And that is how you will be using subclasses inheritance. Okay. So encapsulation makes sure that you have a hierarchy of who can access what. And that is why you use encapsulation. Okay. Hiding the data members from the outer world. Cool. So in the encapsulation, let us say in the same bank account, you should use setter to set the value for the balance and getter to get the value from the balance. It's basically a function where you try to set up the variable for the variable for the data variable called balance. And by getters, what you will do is you'll try to print the variable. It's just that you can't use B1 dot, let's say the bank account name is B1. You have instantiated it. So B1 dot balance, you can't do it. Okay, that's the whole point of doing encapsulation. And this is how it works. Okay. And then constructors and destructors. So you will use constructors and destructors where you need, if there is a class where you need to allocate some predefined values. Let us say we have a, um, let me give you an example. Okay, so let us say we have a class called person, and the person has eye color, hair color, skin tone, whatever. So what we need to do is when we define a person, when we instantiate the person, we need to give all these variables through parameters, and this is called constructors. And destructors is constructors will is a container that gives values to the variables, right? So destructors will clear out the values from the container. Very simple, okay? And then dynamic memory allocation. So what dynamic memory allocation? Wait, I have something for this. Uh, yeah. So yeah, I think you guys can see it. So this is dynamic memory allocation. So by doing this, what you can do is this is from Java, but still, it still works in C++. So this is how you create dynamically allocate memory for objects. Okay, so that you don't instantiate it during compile time, you instantiate them during your runtime. Okay, so this is dynamic memory allocation, and I think you are asked a question where you need to dynamically allocate memory, and uh, I think let me see what the question. Yeah, you have to dynamically allocate a memory, and you have to enter the details for it, and then you have to display like details on car details or something. Yeah. And what you should do is, so first thing you need to do this dynamic memory allocation, and after what you should do is you should allocate values to these members. That's by using a for loop, basic for loop, have a basic for loop, run it for n times, and then cars of I will be the input that you're getting, and then for displaying, do the same thing, use a for loop, and then iterate it over through the whole uh, object called cars. Okay, and this is array of objects, and then friend function. I've already told friend functions. So when you need to use another class's functions and private and protected members, you can use it without having the inheritance as a whole key point. Okay, that is the use of friend function. And this is explicitly used in some cases where you don't need to use every single function from a class. Okay, you need only one function from another class, so you don't need to inherit all of them. Okay, so to, to specifically use for one instance or a specific use case, you can use friend function. Okay, yeah, and then you have polymorphism. Polymorphism is uh, a single thing used in different forms. That is polymorphism. Okay. And we have two types of things. We have runtime polymorphism and we have compile time polymorphism. So function overloading, as you guys will already know. Wait. Yeah. So this is function overloading. So overloading is basically you will be having the same function name, but with different set of parameters. So as you can see here, area, the same function name with different parameters. So, and I'd also like to tell you guys something here, which might be useful. So there is something called as double radius, right? So it is also different. It is also function overloading when the double is also int. Okay, you have the same number of parameters, but even if you change the data type, it's a different function. Okay, you get it? Okay. So I'll tell it again. You have double area and double radius, right? So it's returning some value. And let us say you have another function called double area, and it has int radius. So even if the parameters have different data types, it is a different function. So the overloading happens there also. It doesn't mean to be that the same different number of parameters. If there's only different number of parameters, there is function overloading. No, it's not like that. Even if there are same number of parameters, but with different data types, it is called function overloading. Cool. And yeah, so you need to use function overloading. Uh, this can be used when you have different set of parameters, as you can see here. So areas of rectangle, circle, and triangle, here they've used it here. So in order to find the area, you can just simply give the number of parameters, and with the help of number of parameters, it will automatically know what function is specifically used for the use case. So this is compile time polymorphism, and then overriding. Overriding is done in runtime polymorphism. Okay. So what is overriding? Overriding is basically so you have inherited classes, right? So there is a super class and there are subclasses. An animal is a superclass, dog is a subclass, cat is a subclass. So what we're trying to do is, so the animal dot sound, dog dot sound, cat dot sound, right? So what it does is the parent class has a function called sound, and the subclass also has a function called sound. So what we can see here is the dog has a function called sound. Okay, so when you need to use sound by dog, what you do is you override the function that is there in the superclass called animals.sound. So it happens automatically. Explicitly, you don't need to mention that it is overriding, but this is the whole thing that is going on behind it. Okay, so whenever you do cat.sound, it doesn't say this is generic animal sound. It says cat meows. Okay, and this is called, and the next one is operator overload. I'll get to this. Uh, so operator overloading, instead of so as of now, you guys would know how overloading and overloading happens, right? So it's basically you give a function name and then you have different set of parameters, right? In operator overloading, what happens is your operators are your function name, and the same thing again, it overloads the previous one with the help of the operators. Where does this start to happen? So as you can see here, you don't use the function name. It is invoked when the operator is being called. Uh, wait, yeah. So wait. Here, as you can see, whenever the plus plus tt is called, uh, the operator is being called over there, and then your operator plus plus has been overloaded. So this is what basically happens. It's basically the same thing, but it's just without a function name, without set of parameters. Instead of having a function, when an operator is being used as a function, it's not like you can change the if what it does is basically plus plus is a function. Okay, so whenever plus plus is being called, it will be calling the function called operator plus, which you have already been defined. Okay, so it can also be a function called operator plus, and you can invoke it wherever you're using the sign plus. Okay, so that is operator overloading. And then yeah, you have constructors, right? So constructors can be default constructors as well as parameterized constructors. So parameterized constructors will have a lot of parameters, right? And also constructor overloading is when you have different set of parameters for the same constructor, and that will always happen. And you should know that constructors are by default they're present. You don't need to explicitly mention it, but whenever you want um, different parameters for the same constructor, you need to use constructor parameterized constructor. Cool. Yeah. And yeah, this pointer. So what do you mean by this pointer? So you can put it like this pointer is can be used inside a function where wait, let me just type it out. So this dot value. So what we're trying to do is here is we will be getting a value. Wait, let us say set dot value, not read value. Yeah. So what we're trying to do is we're trying to set up a value, and this is called a function setter, as I've already told before. Uh, so you can try to set a value for the variable called value, and this dot value is basically used. This is you can also do value equal to value, but explicitly by mentioning this dot value, it has an authority over the class's data member. So the public class, right? So this is, let us have a name for it. Um, so let the person have a data member called value, and when you need to set a value for it, what you can do is uh, you can get an input called value. Let us have the same name value. Okay, we are getting the input from the user, that is also called as value, and this is also value. So in order to have a differentiation between them, so this dot value will be used, and this dot value equal to value will set the value for the data member here. Okay, and that is the use of this pointer. You can also use it without the keyword called this, and this is called variable overshadowing. Yeah. So when you have the same name for both the setter as well as the value in the data member, you can use this, and this is called variable shadowing. Okay, and function overloading, operator overloading, and function overriding. So this is basically in your unit 3, and yeah, let me just go through this. So here, as you can see, the plus, right? So here your operator is not defined in this thing. So what you can do is you can have you can have a function where it defines what you should do when there's a plus that is being called. So when the plus is being called, wherever the plus is being called, you will have already assigned a class to it, right? You would have assigned a function to it, and that function can be used here. Cool. This is operator overloading. And yeah, this is your syntax for how you should use friend as well as operator overloading. So as you can see here, he has used friend operator, and friend. This is basically getting input and output, right? So that is what he has done here, and he has done overloading for the input. Cool. And then this is, as you can see here, this is he's using plus plus here. That is wherever you use the plus plus, this function will be called. And yeah, as you can see, whenever there is a number that is given, this will be called, and wherever there is no number that is given, this will be called. That is basically it. And pre-increment is you increment the value before giving out the result, and post increment is you give out the value and then only you increment the uh, actual value for it. Okay. Yeah, and then your UML design. So this is basically what I was trying to tell. Have a class name, and then what are the data members? So memory, double, and memory is your data member, and it has a data type. And this plus, 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 and plus are your access modifiers, and these are your functions. And as you can see here, here they have done function overloading with the help of different set of parameters and different types of data, different types of data types. Okay, and here they've done operator overloading. Uh, so yeah, and then this is function overriding. This is function overloading. Yeah, and then this is pretty important. As you guys know what virtual functions are, right? So I'll just give a quick glimpse of what virtual functions are. So whenever you are trying to use virtual functions, right? Here you don't use virtual function, and what happens if you use virtual function is pretty different. So here I'm using display, a function called display, and a class B also uses display. So what happens is, in terms of overriding, right? So it happens at your runtime, and what happens over there is, if you have a function called void display, it doesn't know, and when you're trying to call a dot display and b dot display, it doesn't know which one to use. Okay, so basically it can point to both uh, a dot display as well as b dot display. So what virtual function tries to do is in the super class, if you try to declare a function called virtual display, uh, it doesn't give priority to any of the other classes. So what you can do is at the runtime, you can decide which one's function, which one's display, you should be able to call the function. Okay. So in order to make it clear, here he has used virtual void display, and he hasn't mentioned where the display has to be done. And as you can see here, he has done a dot display, b dot display. The display is a virtual function. It can be used by both a as well as b. So whenever you're trying to access a, a's display will be printed out. The value of x is whatever, and the value of y is whatever will be printed out when you try to do b dot display. Okay, it's basically implicit, but it's better if you do it with the virtual function. So you will be asked to do uh, questions where you should use the function called virtual function. So as you can see here, so the virtual void, right? So it actually you cannot instantiate this function. It's basically like it's a virtual function where you need to define it and just leave it there, and then the rest of the classes can uh, inherit it as well as use it. Okay, this will be used in function overriding, and I think that's pretty much it. So I hope you guys got an understanding of whatever is there. Are you guys cool? You guys have any questions? I think it's pretty straightforward. You guys should know what each and everything is there. Okay. What I would suggest is uh, have a basic idea of whatever the understanding is. Have there will be a set of places where you need to know why you should use this function. As I told, right? Why you should use what is the exact specific use case where you need to use friend function. What is the need of virtual function? Just know that because you will not be given straight up questions. Give me. You will be given straight up questions saying that give me a solve a question by using virtual functions, but theoretically you need to know where you need to use it. That is when you can apply it to any set of questions that you're given. Okay, so just note down something like this, have it like this. Okay, and then try to understand where and which part of the theory need to be used to the questions that need to be implemented. Okay, so have a set of topics in, like, write a set of topics. Okay, and what I would try to tell is by writing it down, you can generalize it, but there will be a set of places where you need to know when to use it. Okay, so that will be based on the question that you get. Cool. Yeah, Harshada, you're trying to tell something. So that's pretty much it, guys. So okay, okay, cool. So if you guys have any questions, I'm ready to take it. Else, we can just end the session. It's just a basic revision of whatever you guys have been studying. There's not much that there's theoretically that needs to be done. Everything is pretty practical. I've just given you an overview of whatever each and everything is, and the more that type of questions that you can solve from these. So as I've seen your PDFs, there are a lot of questions that they've asked, like exam type of questions. Okay, so I think you guys need to solve a lot more of them. Just chat GPT them, ask it to give more questions like that. I think you guys will be pretty good for this. And I think there's another session by Shravya on Unit 5. I think she will keep you posted. Okay. I think this should be it. Thank you, guys. Thank you. Cool. Bye bye.